Hello and welcome to helpyourmath.com. In this video, we're going to look at solving a system of equations using the method of your choice. There are two common methods that we use. Let's review those now. First, there's the elimination or addition method. In this method, you first decide which variable you want to eliminate. Then you're going to manipulate one or both equations so that that variable has exact opposite coefficients. So for example, if you choose to eliminate x, then you want one x to have a positive 3 coefficient and the other one to have a negative 3 coefficient. Or if you want to eliminate y, you want to make sure that the two y values have exact opposite coefficients. Why do we do that? Because in the next step, we combine these equations by adding the like terms, and when you add opposites, they're going to cancel each other out. That's going to leave one variable behind. Solve for that remaining variable. Now you know half of the solution to the system of equations. To find that other variable, plug in the solution of that variable into one of the original equations to determine the value of the eliminated variable. And then always check your solution. So for a system of linear equations in two variables, we should have two parts to the solution. Most commonly an x part and a y part, which you can write as an ordered pair. You can always plug those in, make sure that it's a solution to both given equations in the system. The other method that's really common to use is the substitution method. For the substitution method, we want to isolate one variable in one equation. So either get x by itself in one equation or get y by itself in one equation. Then substitute for that variable into the other equation. So once you have x isolated, it's going to say x equals blah, blah, blah. Take the blah, blah, blah and plug it in for x in the other equation. You now have an equation in one variable. Simplify that equation, solve for that remaining variable, and then just like the other step 5, plug in the solution of that variable into one of the original equations to determine the value of the substituted variable and check your solution. Okay, so our first example, I don't know which method is going to be better yet because I'm not a great judge of fractions. So what I think we should do first is eliminate the fractions. How do we do that? By finding something all the denominators go into, rewriting each term to have that common denominator, and then using the multiplication property of equality to multiply by that value, which will cancel all the denominators. It sounds complicated, but it's actually not that bad. So taking this first equation, we have a denominator of 4, 2, and 3. So 4, 2, and 3 all go into what? They all go into 12. So what I want to do is rewrite each of those fractions to have a denominator of 12 by multiplying by a factor of 1. What do I need for this 4 to become a 12? I need to multiply by 3. So I'm going to multiply by 3 over 3. In the middle, I need to multiply 2 by 6, so I'm going to multiply by 6 over 6. And all the way over here, I need to multiply by 4 over 4. And so then what that gives me is 3 over 12x minus 6 over 12y is equal to 4 over 12. And then what I can do is multiply this entire equation by 12. And what's going to happen when we distribute the 12 is it's going to cancel out all these 12s in the denominator, leaving behind 3x minus 6y is equal to 4. Okay, let's do the same thing with the second equation. Here we have denominators of 3, 2, and 3. So what do 2 and 3 both go into? If you want to use 12 again, you can definitely use 12, but smaller than that is they both go into 6. So I'm going to multiply by factors of 1 so that all the denominators become 6s. So I need to multiply here by a 2. So 2 over 2. Here I need to multiply by 3 over 3. And then here I need a 2 over 2 again. That's going to give me 4 over 6x minus 3 over 6y is equal to negative 8 over 6. And then what I'm going to do, I'm going to use that multiplication property of equality to multiply by 6 to every term. That's going to cancel all of those 6's in the denominators, leaving me with 4x minus 3y is equal to negative 8. Okay, this looks much better. Now I know for sure that I want to use the elimination or addition method. If I use substitution, I would have to get a variable by itself, and that doesn't look good. We're going to end up with fractions if we do that. So using the elimination method is going to be our winner here. And so what we need to decide is which variable do we think will be easier to eliminate. And in this case, I think we want to eliminate the y because we have a coefficient of 3 or negative 3 and a coefficient of negative 6. So since 6 is a multiple of 3, that's going to be a little bit easier to work with. We only need to deal with the second equation. We only need to manipulate the second equation. So basically what I need to have happen is I need negative 3 to turn into the exact opposite of -6. Well, the exact opposite of -6 is +6. So I need to multiply, let's see, I need that to be a +6. I need to multiply this by -2, right? Because that's going to give me a +6. But I can't just willy-nilly multiply one term. I need to multiply this entire equation by -6. So that's going to give me here in this second equation, oh, sorry. I need to multiply the entire equation by -2. There we go. That's better. Okay, so then I distribute the -2. The second equation, I get -8x plus 6y is equal to +16. And then this top equation, I'm just going to rewrite it here. 3x minus 6y is equal to 4. And now I'm ready to combine these equations. -8x plus 3x is -5x. These should eliminate. That was the point of the elimination method. And 16 plus 4 is 20. Now to get x by itself, we'll divide both sides by -5. And we figure out that x is equal to -4. So I know I said previously that we should use one of the two original equations, but I think we want to use one of the manipulated equations, one of the ones that we started this portion of the problem with. We can always check our work. Maybe we'll check our work with the other one, but it'll just be a little bit easier, I think, to just use one of those two. And I think the bottom one is a little bit easier. So where's the bottom one? This one. I want to use the second one. So I'm going to plug in 4, and I'm replacing x with -4. Minus 3y is equal to -8. 4 times -4 is -16, minus 3y is equal to -8. We're going to get y by itself, so first I'm going to add 16 to both sides. That's -3y is equal to +8, divide both sides by -3. We end up with a fraction, and y is equal to -8/3. So I feel fairly confident that the solution here is x equals -4 and y equals -8/3. Since this is in terms of x and y, I can write it as the ordered pair x comma y. But like I said, I do want to check because I like knowing that I have the right answer. It helps me catch mistakes when I don't. So I'm going to check by plugging in -4 for x and -8/3 for y into that top equation with the fractions and all. So we're going to plug in 1/4 times -4 minus 1/2 times -8/3. And we want to know, does that equal 1/3? Okay, well, 1/4 of -4 is -1, so that's not so bad. A negative times a negative is a positive. This becomes a 4, this becomes a 1, and we end up with -1 plus 4/3. If you're not super comfortable with fractions, create that common denominator, right? We're going to add them, so we need a common denominator. We need to rewrite this one to have a denominator of 3. I get -3/3 plus 4/3, which does equal 1/3. So yay! I feel like we did something right. I feel very confident that -4, -8/3 is the right answer using elimination. Okay, how about this this problem here? Okay, let's try another one. So in this problem, I see decimals. I think I want to clear out the decimals. Much like fractions, I tend to make more mistakes with fractions than with integers. Same thing with decimals. I tend to make more mistakes with decimals than I do with integers. So I'm going to get rid of these decimals. How am I going to do that? Here we have a 10th, 10th, 10th. So I'm going to multiply this top equation by 10. And that's going to move all these decimal points one place to the right, giving me 3x plus 6y is equal to 18. The second equation, I have 10ths, 10ths, and 10ths, so I can do the same thing. Multiply everything by 10. That's going to give me 2x plus 4y is equal to 12. And now it's up to me or up to you which method we want to use. Since we used elimination last time, I'm going to use substitution this time. I think it's going to work out okay. And what I'm going to do is I'm going to rewrite this equation to get x by itself. So the first thing I'm going to do to get x by itself is I'm going to subtract 4y from both sides. This will leave me with 2x is equal to 12 minus 4y. Now I need to divide each term by 2. So this was a little bit risky because I'm dividing, but 2 is even and so is every other coefficient. So I know everything's going to be divisible by 2. And I end up with x equals 6 minus 2y. So now what I'm going to do is I'm going to take what x is equal to, which is 6 minus 2y, and I'm going to replace it in that top equation. So we have 3 times 6 minus 2y, right? And I'm substituting out x for what I know it's equal to based on that second equation, which was 6 minus 2y, plus 6y is equal to 18. Okay, I'm going to distribute the 3 here, so I get 18 minus 6y plus 6y is equal to 18. Wait a minute, the y's cancel. So I end up with 18 equals 18. So what does that mean? Did I do something wrong? I'm pretty sure I didn't, and the answer is no, I didn't. We ended up with a true statement. What this means is that these two equations that we were given are actually the same line. They graph the same line. So these are equivalent equations. What this means is that we have infinitely many solutions. Anything that's a solution to that top equation is a solution to the bottom equation. So we say this one has infinitely many solutions. If we were to graph this, what it would look like is it would just look like one single line because it's called they coincide. They're right on top of each other. And so we have infinitely many solutions. And if you want to check your work, if you want to make sure, wait, is that really true? You can plug in any number. So plug in, 1 for x and see what the value you get for y is and make sure that that works for both of them. So if you get 1, 3, it should work for both the top equation and the bottom equation. And if we did want to verify, so you might be like, wait, I'm still not convinced. What we could do is get x by itself in this equation, and it should match this x equals 6 minus 2y. So if we were to get x by itself in that top equation, the first thing I would want to do is subtract 6y from both sides. And we get 3x is equal to 18 minus 6y. Divide everything by 3. And we get x is equal to 6 minus 2y, which is exactly what we have here. So they are in fact the exact same equation. They just look a little bit different, right? One's wearing high heels, one's wearing a boa. Because they're the same, that means there's infinitely many solutions. And just to reiterate, I chose to do substitution, but we could have also done elimination here and ended up with the same result, right? If I want to use elimination, maybe I get these both to have coefficients of some type of 6, whether it's positive 6 or negative 6. And then what would have happened is the x's would have canceled, the y's would have also canceled, and we would have ended up with 0 equals 0, which is also a true statement indicating infinitely many solutions. Okay, for our last example, do you see which method is going to be the better method to use? Say it with me. Substitution. Why do I know substitution is the better method? Because the second equation already has y by itself. So what we're going to do is we're going to take what y is equal to, 2/3 x minus 4, and substitute it in that first equation where we see the variable y. You could multiply that second equation by 3 and use elimination, that's fine, but I think that's going to be a little bit more work than the substitution. So we're going to take that first equation, 2x minus 6y, but instead of y, we're replacing it with 2/3 x minus 4 is equal to 8. Now we want to distribute the negative 6, so we're going to have negative 6 times 2/3. Maybe you want to put the negative 6 over 1 while we multiply. I like to simplify before I multiply, and I know that both 6 and 3 are divisible by 3. And we end up with negative 2 times 2 is negative 4 over 1, which is negative 4. Hey, look, the fraction's gone. This will be minus 4x. Distribute the negative 6 to the negative 4. That gives me positive 24 is equal to 8. Combining my like terms, 2x minus 4x is minus 2x. I'm going to just go ahead and subtract 24 from both sides, equals negative 16. Divide both sides by negative 2, and we end up with x is equal to positive 8. Okay, we're halfway done. We have the x, we need to figure out what the value of y is. You can use either equation. I might, since the second one already has y by itself, I think I'm going to use that one. We have y is equal to 2/3 times, and instead of x, I'm substituting in 8, minus 4. I'm going to put 8 over 1. I can't simplify before I multiply. I'm going to end up with 16 over 3 minus, and since I'm going to be subtracting fractions here, I know I need a common denominator. So the common denominator between 1 and 3 is 3, so I'm going to multiply that minus 4 by 3 over 3, giving me minus 12 over 3. Now I can subtract 16 minus 12 is 4 over 3. So I end up with a solution of 8, 4 over 3. And if you want to check your work, you definitely can by plugging, I would plug in 8 and 4/3 into that top equation. So that's going to be 2 times 8 minus 6 times 4 over 3. Does that really equal 8? Let's find out. 2 times 8 is 16. Minus, I'm going to put that 6 over 1. I'm going to simplify by dividing by 3. I end up with minus 8. 16 minus 8 is 8. I feel very confident that I have the correct solution in 8, 4/3. These have been examples of deciding which method we want to use for solving a system of equations. Thank you for stopping.